Dr. Tung. Okay, Dr. Tung was with me in Texas Instrument before, then in our church. Then he went to the Southwest Medical Center and did if I remember, neurology study, neuroscience, I guess, as a PhD. Then he's very good at big data. And then he joined AT&T. Then he went to the Microsoft. And you're in the Amazon now or is it Microsoft?
I'm in Amazon now.
Yeah, now he's in Amazon now.
Yeah.
So quite a career. So let me give the baton to Casey. And for next two sessions, Casey is going to share his experience with you. And don't hesitate to ask a question in the chat room. I'll bring it up to him. Okay, thank you.
Okay, yeah, thank you, Ming. Please, forward me any questions they have in the chat room. Anytime, feel free to interrupt my train of thoughts or the content of my talk. I'd like to address people's question in a timely manner. So really appreciate you monitoring the chat room. And my name is Casey Tung. I guess from the intro or brief that Elaine sent out via email a few days ago. I hope that everybody has a chance to take a look at some of my demographics and background. So unless you have specific questions, I will go into a little bit more about those. But long story short, I've known Ming for more than 20 years now. And we serve in the same church, in different organizations, different ministry throughout all this time. And I do know that Ming has a passion for help and guiding and leading young professionals or youth starting to going into career choices and planning for their own future. And Ming has a specific passion for such a topic. So that's why Ming brought me along for today's and next time's talk. Basically, I need to share my professional journey and be able to help provide some insight and provide some guidance to all the audiences here today. So very glad to be here. Okay, first of all, I guess my job title, my job function related to what I do at my role. Currently, I'm a senior solution architect for Amazon AWS. And AWS is a very big organization, as you know, being the leading cloud vendor in the public cloud business. AWS has the biggest market share. But that also means that we provide so many different services from IT levels and to meet IT levels needs. So the division or the organization that I belong to is actually building and designing and building computer chips for AI applications. So think of it like NVIDIA, except for it's owned by Amazon and built for Amazon. Our chip is built and designed in-house. Well, we outsource the building and the fabrication process to the foundry. Like a lot of different companies, they customize and design their own AI application chip and have it built, whether it's in Taiwan or in China, or assembled together into a big server in Mexico. So long story short, if you go on Amazon AWS and you request to have virtual machines with different CPUs, with different accelerators, you will find our product in there. Basically, it's a custom designed, custom built FPGA that serves to accelerate machine learning and AI applications for the inference at the fraction of cost of NVIDIA GPU. So that's a little bit about my group's product and services. And now let's talk about my role. As a solution architect, my role is to help our customer, mostly internal, sometimes external. Internal ones being like Amazon retail website. Amazon retail website has a lot of different services, one of which, the most important one, is probably search. their search engine business, as well as Alexa. So how many of you actually use Alexa or have Alexa at home? Okay, all right. So I see a few people definitely use Alexa. But did you think about the back end of Alexa, where when you utter a sentence or a request, it gets sent back to Amazon's own cloud. And Amazon's own cloud recognize your voice, they understand, or at least they can map what you're asking and then retrieve information back to you. That entire process happens in cloud behind Amazon's firewall within Amazon AWS service. That is powered by our chip. My division, my organization's chip is the powerhouse behind it to process billions of verbal transactions. It's called voice to text and text to voice coming back to you. You listen to Alexa speaking to you, but it's really a voice to converting to text, text converted to enable a search engine to look up the information that's being asked by the user, and then transmit it back to your home, to your Alexa device, and then utter back into a voice that you can understand. So that's the capability of AI application nowadays. And you can imagine that any kind of delay or any kind of inaccuracy or giving you the wrong information, that really hurts the user experience. So the demand nowadays for AI application, at least from the Alexa example, is that you got to do it really quick and immediate, and it has to be right, and at least 80% right in terms of information coming back to you, right? Now you can imagine that if you apply this to self-driving car or some kind of autonomous system, this becomes even more mission critical, right? So now people have this level of expectation for AI and machine learning applications. It becomes even more important that from a business perspective, you want whatever you provide, the AI service, to be as low cost as possible so you can scale, so you can serve the market, you can serve the millions of users at the same time. So that's what Amazon AWS is doing. That's why my organization enables our customers to do. And then besides that, we also have external customers that provide specific services, such as a chatbot application for any company, right? If you go onto any consumer-related company website and then you engage with their chatbot, this sort of a service really runs in public cloud nowadays, more often than not. Again, people expect the response to be fast. At least the chatbot is supposed to recognize that, okay, I cannot process your request. I'll relay you to a live help or live operator. Would you like to have a callback? So these are sort of the AI machine learning services that you start to see more and more nowadays. And people demand and users demand and expect fast and immediate response. Whether you can get it right or not, that's a different story. But at least from a service perspective, you want to use AI and machine learning capability to kind of triage the user intention, customer requests, so forth, at least routed you to the right direction or the right phone number so that you can speak to the right person to kind of help you if the AI machine learning cannot figure out exactly what you want, right? So my role is to help these customers, external and internal, deploy their model, their language model, or their computer vision model in our cloud, and make it as fast, as efficient as possible, running on our chip. So that's my job function and my job role. And so, is there any question?
Yeah. What do you mean by model? Like language model, vision model? What do you mean by that?
Okay, a model in terms of AI and machine learning application is let's just say a piece of a software code or code, let's just say a source code that can map one set of the data, input data, into some kind of output data of the different or similar format that can be used by the end user. So think of it like a mapping process, right?
Okay.
You have an X, and then go through Y equal X squared, and then Y is a value of X times X. So it's really just a mapping process. And the model itself, more often than not, is a static, kind of a deterministic mapping, because after you build the model, you train the model, the parameters are all fixed. Then any kind of input you put it in, unless there's some kind of a random generation involved in any kind of the process, then you will always get the same response back. So that's the limit of machine versus human being. Objectively speaking, those are the differences. Whether it's good or bad, I think it depends on a lot of things.
Can I ask a question?
Sure.
Yeah. So are you on the software end or the chips or the hardware end?
I'm on the software end. The product I'm responsible for, the team I'm on, built and designed SDK for the end user, because you have these awesome FPGA hardware that can calculate, that can do a lot of computation at a very quick time cycle. But for the end user, they really need a software stack to be able to access and leverage the use of the hardware. So that's where SDK comes in, and we provide that SDK. That's our product, and I'm responsible for making sure that our SDK can support different kind of a language model, different kind of computer vision models, say for object detection, for example. If you feed it a string of video, or you feed it a batch of images, the model can draw on the image or draw on the video frame that's a human being, that's a coffee mug. So this has to be done at a very, very fast speed. So the more efficient your model can run on the piece of the hardware, the better. And I think to NVIDIA's credit, that kind of methodology or framework to accelerate a AI machine learning model, to their credit, they're the first company to actually make it feasible. So again, you have a very specialized, very powerful hardware, but user access the hardware via a software stack, and that stack is commonly known as SDK.
Just one more question, because I research a lot about depression, and every time I type Google research search, I type feeling blue, and then the first thing come up is do not commit suicide, and here's the number. Yeah. Why is that?
Okay, that's actually much better than what it used to be in terms of Google's capability or language, or their language models capability to kind of make the best educated guess what you actually mean. Because you have what you put in a Google or in any search engine is what we call an utterance. And that utterance, nothing more than a string of letters and space and words, right? Within that contains what we call semantics. Semantics actually is somewhat related to your intention, okay? What does the word blue mean in this particular context, right? It could mean color, it could mean mood, and then it could mean other things, right? It can carry a lot of different meanings. So that's what we mean by semantics. What does semantics for this particular utterance actually mean? So actually, it's pretty good that it kind of take the best guess that, okay, it's about depression, it's about mood, rather than about color. You know, in the old days, it will probably interpret it as a color. So that tells you how powerful a language model can be. If you have all the data or all the text or all the document in the world, you can potentially train and build a model that can have the best guess to be the most likely guess of your utterance. Yeah.
Thank you.
So how big is the AWS organization? Then how many people doing the system architecture? Then how many people do the software coding? How many people do the hardware design? Have any
Quite
idea?
a lot. Yeah. Overall for AWS, I think we're looking at about globally, perhaps 200,000 to 300,000 employees, full-time employees. Of course, a lot of those, I want to say maybe like 1/3 to 1/2 of it are like technical sales people, meaning the people actually work with customer every day on the technical side, that is, right? And then you have a bunch of people scattered in different organizations. Basically there are two organizations, two major organizations in Amazon. One is the Amazon.com, as you all know, the retail site, right? That handles the retail logistics. And then the other one is AWS, that's us. In terms of these two major organizations, we do cross-pollinate. We do have a lot of interactions going back and forth because we serve each other, really. I can't really tell you how many people are doing the design because it's a very scattered matrix organization. It's not like I have a department that does hardware layout or tape out. It's not like that.
What does AWS stand for?
Oh, Amazon Web Service.
Amazon where?
Web.
Oh, Amazon Web Service. Okay, okay. Amazon Web Service.
Yeah.
AWS. Okay.
Yeah.
I got it.
Go ahead.
Okay. Let's see. I noticed in the chat room there are like 6 different questions. Let's see. Maybe I should look at some of the questions.
Oh, that's okay. No.
Okay.
At this moment, I'm reviewing for you.
Okay.
I don't think they have any questions.
Okay.
Some
All right.
comment.
Okay, no problem. Then I'm gonna move on to talk about my daily life and what is it like for my daily job, right? So daily life and daily job. I work from home. My organization and my department and my peers and my managers are in different places, but most of them are in Cupertino, in California, in the Bay Area. And then my colleagues, my peers are scattered all over the world. Some in Taiwan, some in Tokyo. There's one in Alberta, Canada, and I'm here in Dallas. And we all work across different time zones. But so far, my manager seems to be okay with it. In fact, I think my manager and their team originally came from Israel. And it's a company called Annapurna Labs. And let me just type it in the chat. For those that are interested, can do a quick Google. So Annapurna Labs used to be a startup company, custom with a skill and knowledge to custom build silicon chips and then have it manufactured in the foundry. This used to be a startup in Israel, maybe like 7 years ago, 8 years ago, that Amazon acquired it. Amazon acquired it and has a vision to say that, okay, well, NVIDIA is building these GPUs that's very powerful, and why can't we build something on our own and make it cheaper than NVIDIA so that we can broaden the machine learning and AI services, make it as cheap as possible for customers. So that is a vision. And that's how come Annapurna Labs became part of AWS. And once that happened, of course, a lot of employees from Annapurna Labs gets relocated. Some of them came to the Bay Area. Some of them is in Seattle. And then, of course, there are ones that are scattered all over the world because as we expand, we start hiring to support different customers in different time zones. So we all work across different time zones, definitely. But everybody have their own life and the work balance. Take care of their children, take care of their family, go to sleep. So yeah, it's a global. Even within our small organization, it's pretty global in terms of reach and in terms of how we work with each other.
So if you work at home, compared with work in the office, what do you feel the big difference about your lifestyle and the?
Well, for the office work, if you have a colleague or if you have your team nearby in the next cubicle, you can sort of kind of just very quickly say, I got a question for you. What about this? What about that? Here, let me show you. Here's what I see, right? So what do I do? What was your experience when you run the same source code? Do you get the same bug or do you run into the same issue, right? So we can quickly do that. When everybody's working from home in different locations, you cannot do this as easily, right? So you kind of rely on your own to figure out some of the answers, or at least go through a triage process. Because when you get somebody on the Slack or on the chat, the first thing people tend to ask you is that, okay, what have you tried, right? So that's the first thing, right? And if you say, okay, I don't know, I haven't tried anything, then that's not a really good experience, right? They're trying to help you. They're trying to help you determine or at least troubleshoot some of the experiences or the problem that you see, right? So you kind of have to take the first initiative to triage your own question, your own dilemma first. But working from home has its advantage as well, definitely. You save a lot of time to travel on the road, seriously. At least for Dallas, if we were to go anywhere within the office, you're talking about like 15 to 30 minutes travel. If you go through tollway, and Dallas have plenty of tollways, which means that you have to pay a toll tax fee to go through, so you can avoid the local traffic and the red lights. It really adds up. So save you time. If it saves you time, it saves you money, right? So in that regard, if everybody's productivity as well as their own intellectual contribution and they do their work, then I think company can be run just the same, just as well. So nowadays, hybrid workspace, work from home is really like a very legit trend now. I don't think it's going away.
Yeah, thank you.
Okay. And I think Ming also was asking me about describe some of the tools or the setup that I use at home to do my work. So let's see. When it comes to AI and machine learning, at least at the level that I'm dealing with, I think programming languages such as Python is very important. Python wasn't my first computer science language, but it's important enough that I spend enough of time early on, back in my AT&T days, that I start to pick up and learn. Like learning any languages, spoken or programming, regardless, understanding the details and nuances and semantics is really time consuming when you first get started. But
you keep saying semantic. What is that? I'm sorry.
Oh, the meaning of a particular word as in the entirety of its sentence. So if you think about a line of code, there's a keyword. What does that keyword mean when you look at that? So that's what I mean by semantics.
Okay.
Yeah. So think of it like meaning. Like, what does it mean? What does the word blue mean in this entire sentence?
I'll just interject a little bit. I used to look down on people who are linguistic major, and I thought they were not until that I met a guy from the pastor's son from Singapore, and he came here to study linguistics. And I thought, what a dead-end major. And he said, no, I work for the Defense Department. I analyze.
Oh, yeah.
He does just like you said, AI on social media, and he's trying to pick up words, keywords that would lead to social unrest. And he's on more than 6 digit. And I thought, wow, I'm sorry, I didn't know that the linguistic can earn that much. Yeah. Okay.
Yeah. Daily job, daily programming language, Python is important, and then as far as the tools, all my work is done on the web, on the AWS infrastructure. So be comfortable with public cloud is very important. As far as the IDEs or the interface that I use, Visual Studio Code is probably my go-to tool. Let me put it in the chat. So, for those that are interested or that are dealing with computer programming, Visual Studio Code is my tool of choice when it comes to programming. Of course, there are other things too, but I see more people using Visual Studio Code than anything else. Okay. I think somebody was asking, what is the difference between electrical and electronic in career choices?
That's okay. I can cover that in my sharing later. Yeah.
Okay. All right.
Focus on your software system. Yeah.
Okay. All right. No problem. Let's see. Another element of my daily work is to address customer concerns or attending calls with either internal or external customers. And in this kind of a workspace environment, I think it's very important that you get very clear picture of what your customer or what the other side is talking about. And if there's any doubt, clarify it. Don't feel like I'm asking a stupid question or, oh, I forgot. What did you just say? You don't want to leave any ambiguity in such a way that it may come down later to bite you. So in AWS, at least in my organization, we're very big on getting down to the fact, getting the objective fact, and get the information necessary and useful information. We're not like trying to collect everything, all the pieces, because human brain would just explode, right? If you all of a sudden you got too many information going at once, right? So we stress on what's the most important one. What does it entail? What does it imply? What are the important facts? Who, where, and what has been done? What are the next choices? What's the end goal? I think that's also very important during our interaction and conversation in a meeting or with an external or internal customer or partner. Yeah.
We have some question here.
Okay.
What kind of language does a server use? People do the other.
Server, I think it depends on the back end or front end. If it's a front end, it's most likely JavaScript or PHP, something like that. If it's a back end, then it could be Java, it could be C++. It depends on the system and the purpose of it. For AI, for AI and machine learning, tends to be C++ and C when it comes down to the machine level of code.
I have a question. How do you learn all this language? Because the language evolving quick, right? Change quick, and you cannot just keep going to school. So do you always self-taught? Ming is quite correct. When it comes down to learning computer languages, a lot of languages come and goes, right? So what I do typically is tend to focus on what's the most fundamental ones, right? You talk about software stacks. I think I talked about the software stacks
many times in this conversation. But from the computer language perspective, you have the assembly code, you have the APIs for the C++. For C, for example, and then on top of that, you have a higher level construct, such as Python-based or specific computer language-based data structure, if you will, and then go on, right? And then towards the top, you have the SDK that's more user-friendly for a computer programmer, right? To focus on which layer depends on your role, your job role. If I was a compiler engineer, then it's very important for my skill to center on C, C++, as well as maybe machine level code, but maybe not so much. If you're dealing with the hardware folks, then machine code is important. But that all depends on your role, really. For my role as a architect, solution architect, I tend to focus at the top level, which is the Python data structure level. So knowing that and knowing that machine learning and AI is going to be, I want it to be in my career path or career choices. I want to be in that particular field. I want to be doing what I do. Then it becomes very obvious to me that Python is a language of choice that I need to master. And then on top of that, you have different kinds of machine learning libraries specific built to construct and train a model. So then you're talking about open source ecosystem like TensorFlow or PyTorch, if you will. Let me see. Let me put it in a chat. So for those that are
one
reading
question.
chat, yeah.
Go
ahead.
All the youth, if they want to be the AI expert in the future, and they like to self-taught some computer language now, so which language do you suggest they just start playing with it and doing something with it? And then, of course, is how do they learn from the web? How do they self-taught that?
Okay. I think first you want to find what you're comfortable with. In terms, every computer language has their own constraint and has their own ecosystem or workable space, right? Like I just mentioned, assembly code tends to be related to like a hardware design people, right? And then on top of that, you have the middle layer, the firmware level. That's more related to C, C++ operator at that level, right? So if you want to learn like if you never get into that deep of level, which I never did, right? At the machine code level, never really did in my life. Then I probably won't go there for my career. So then I focus on, well, what kind of interests me? If you're just starting to learn computer science, computer or machine learning and AI, these kind of things, I would say Python is probably the go-to choice. Pretty much 99% of the time. So if you're talking about C, C++, those are a little bit more primitive than Python now. However, nevertheless, it's important. But the kind of problem or problem set that they're dealing with tends to be operator related, algorithm related. So think of it like when you design a compiler, what are the skills? How do you make the algorithm run faster? How do you parallelize something? A particular for loop, for example, how do you parallelize it? Okay, that's at the C, C++ level, which is very fundamental and very important. But it doesn't help you see, oh, wow, okay, I can build a model that can understand the meaning of a sentence, right? So different level.
So how about for the entry level people, like youth, and they have some time in the summer, and they have time during the weekend.
Yeah.
They really like to get into something, they can enjoy it, they write something, they can show everybody.
Yeah.
What do you suggest?
I would suggest starting with Python. And if they can learn well enough, or at least they can feel comfortable about Python programming, then go with it and then start to develop something. If it's AI application, then look at computer vision, look at large language model, then go from there. So that's what I would recommend.
So can you give them like if you're a supervisor or instructor, you want to give them a small project to do and start with the Python, what kind of project you tell them to do? They're just, you know, high school students, juniors, high school, middle school students.
What are usually being done is like a computer vision problem, or some kind of a large language model problem, such as a language classification. For when it comes to text and languages, this is actually very important. For the computer vision, there's a lot of variety. For example, image classification, the painting behind you in your background, for example, can we identify knowable or known object from the painting? So I see a boat here and there. I see a house. I see water. I see different buildings. You know, image classification and segmentation problem. These are some of the things that I believe that, you know, if you are proficient with Python programming and you feel comfortable looking at some of the source code, then this is a good start. And then of course there's a combination of language and computer vision problem. For example, if I have a PDF, which Adobe system as a company, they make a business out of it. If I have a document and I want to classify these documents, but these documents are PDFs, right? They're not a string of text, right? Now, how do I classify them? So this is not only a text classification problem, like a language problem, this is also an image problem, because your native data is presented as a PDF or an image, right? There's a lot of combinations such as this. Yeah, and then another very interesting problem. I would challenge people that's interested is that we all use a banking application, right, on your cell phone, right? You take a picture of a check, and then it automatically deposits into your account. Think about it. That's exactly what I'm talking about. It's a combination of a language and computer vision problem, right? It has to know where to read your account number. It has to know how much the amount people are writing down on the check, right? Those are handwriting, right? Or sometimes it's a type, but nevertheless, it's a combination of computer vision and language model. So how do you think, can you build a model that can do such a thing? You know, so that would be one cool summer project.
I think that very interesting. Let me make some comment. You know, basically, the Dr. Tung talking about is pattern recognition. Okay.
Yeah.
So pattern recognition, of course, the easiest way is start with the static pattern, like a picture of a girl, of a boy, of a tree, is static. Okay. And then like if you sing a one tone, do, re, mi, fa, sol, as a static. But however, once you put a static into a sequence, it suddenly become more dynamic now, okay? Like a language use a lot of tone together. And then the language itself has a lot of intelligence in there. And the static picture become a video. That's another story, okay? And like writing, that's a pattern recognition. So much intelligence in there. So that's very challenging, interesting thing. So it's I think AI is a never-ending territory you can keep exploring.
Yeah, exactly. In fact, I noticed some of the questions kind of follow up on what Min just said. That it's an exploration. And there's always challenges. One of the questions is asking about, okay, how does it know it's a forged check? Or how does it know how to read your signature? Well, it turns out that when you do that, when you use an app to deposit a check, you have to do it twice. Once in the front and once in the back of the check where you endorse it. And when you endorse it, you have your signature. So, and a bank hopefully have your signature on file through all the previous document or check that you have. They can kind of tell based on the AI that if this signature matches with the one they have on file. So that's how it's done. Now, as to the forged check or whether this check is legit or well, then that becomes a question of cybersecurity in banking, right? Typically, when you go to a bank lobby, you deposit a check physically. They kind of hold it for a while until they can verify that the one that writes you the check actually have the fund. Then that becomes your money because you know, that's just part of the routine for banking. Yeah.
Very good question.
Yeah. One last question. Could I just share with this that I just many of the our kids here, the parents probably showed them this already. The youngest self-made billionaire, Alexander Wang, who dropped out of MIT at 19, and his company is Scale AI. How come none of us could be like that, or our kids couldn't be like that, or how come you didn't think of that?
Well, first you got to understand. I think persons like this, genius like this, only comes, you know, maybe every 50 years or so. So he's definitely an exception, right? There's a one Alex Wang, but there's probably hundreds, not Alex Wang, right? Yeah. So I think what he has is he's willing to try, and he has what it took to be successful before his money or his energy or his focus right now. I really think that's very unique. He's a very unique person. But without knowing too much detail as to how he get to where he was, I think I'll just leave it at that. For most of the people, I think you go through the education process, and that's more formalized, and you may have a vision, but what I want to focus on is everybody has a vision and passion. And first of all, I think as we grow older and older, it becomes even more important that your vision and your passion is something that you can sustain for a long time. Meaning that you're not just going to, okay, well, I'll try it, and if I failed or if I hit a roadblock, I'm just going to quit. Okay. So I think for young people, it's very important that when you apply for college or graduate school, I think at least from my experience is that the admission office first triage your scores, right, your GPAs, right, and then they look at the substantive content of it, the more subjective content of it. But nevertheless, there is some kind of an objective behind it, which is they're looking for students extracurricular activities or academic engagement, such that it's outside of their grading system, but then that's something that they sustain for a long time. If you go to volunteer in a food bank, how long have you been doing it? And do you have any result that you can show? Or if you volunteer at a hospital, how long were you doing it? And what did you get out of it? So those are only some questions. Those are only things that you can write or let's just say brag about. And if you have done it for a long time and you sustain it, and you sustain it in a way that helps you grow as well as help others. So I think to be successful with your passion or with your vision, there has to be something like that burns a fire inside of your belly.
Thank you.
Yeah, my comment, I think, is very important things. That's why our youth camp on Zoom for this series is to let you find out what are all the job and what do they do there. And if you find someone specific, you're very passionate about it, and you like to spend all your leisure time working on it hard, and then you should do it. Okay, you should do it. And that make you way ahead of everybody in a specialized area. Okay, like software programming, and Alex Wang did it. And so if you're specialized in something, way ahead of everybody from age point of view, you're a potential billionaire if there's a market for what you like to do. Okay, so this is very important. The first thing, Alex Wang don't waste a lot of time playing video game, sitting around there doing nothing, I'm pretty sure. And he spent a lot of time study the computer and study the Python and study writing the computer software and have his own project, set up a goal. He probably started doing that 7 years old, 8 years old. Okay, so anything that trigger you and make you have a strong passion to do it, and then you know the world need it, and there's a value there, there's a business there needed, you're in. So you'll be a billionaire. So the way I see in this whole world now, every profession is getting younger and younger.
That's right.
Okay, like a golf champion, 17 years, 18 years old, and like a tennis champion, 17, 18 years old. Software computer, 18 years, 19 years old. They're all like that. Okay, so the reason is this whole system is more free, have more freedom now. You can do as long as it's right and you have passion, you have talent for it, you can be very successful in a very young age from money point of view and utilize of your talent point of view. Does necessarily mean you become a better person? A separate story. That's why we want you to be successful, but also a good person to make this world a better place for everybody. Okay, that's what I want to do. So I believe every one of you have a potential to be a billionaire before 25 years old. Okay, I believe so. But then just make sure you fully utilize the talent God gives to you. You pray all the time. You find out what the passion, and just go for it. But don't waste time. Don't waste time. Okay, that's the most important thing.
Thank you.
I'm glad that Ming brought up the fact about don't waste time. I think it's very important that I've seen some kids that are really, really super smart. When they dig into a subject matter, then they're really going down nitpicky and then start to looking for a needle in a haystack and then lose the whole picture, right? So that's actually kind of a mental deficiency that those kids actually have, which is that they just drill down the hole and dig a hole for themselves, and they could never get out of it or get anything out of it or get anything done. So I know from us, people who have no such a problem, it's easier to say that, oh, well, you got to be purpose driven, you got to set your goal, you got to know how to measure success. But can you imagine kids with certain mental or neurological deficiencies that just doesn't have that thinking process? They get obsessed with something, and then they keep going down and basically dig a hole for themselves, and nothing gets done. So you want to be careful. So what I'm saying is that having a way to measure success, having a way to recognize that what is your end goal, what do you want to get, and then do it step by step. You will have a small goal and set it up in a timely manner, and know how to measure your success or delays, and then find the therapy or recipe for fixing it, and then move on to the next goal. So incremental goal, but then you have a time measure, you have a time-bound measure for these incremental goals, eventually driving towards how you define the success. That's very important.
There's one question here, say, what do you think the audio application in AI, like Alexa always interface human language? Okay, what do you think is the future for audio application?
For the audio application, I think voice to text, customer help, that's definitely one thing. And for some of the activities we engage, for example, when we're driving cars, we want to do something with the entertainment system, for example, or you want to change a radio station, or you want to change a Sirius satellite station, or you want to tell car to do something, but then you don't want to diverge your visual concentration from road to the dashboard, right? So that's where voice to text or audio application comes in. Very important. Hands-free application, mission critical application where you cannot shift your concentration. So that's one audio application. Another thing would be some kind of a abnormality detection, right? Detecting abnormal sound, detecting sound that actually means something, that actually means danger or should be alert for something. Audio application in AI is pretty important, right? For theft deterrence, for security, for physical assets security. I think sound as well as computer vision are all very important and interplay very much together.
Great. I think we probably need to end the session today. Okay, it's a very fun discussion. Okay, so next week and Casey come back again.